Can everybody hear me okay in the back as well? All right. So good morning, everyone. Today, my name is Yilin, and today I'll be presenting the HR 873, Water Quality and Environmental Innovation Act. So what does the bill actually talks about? From the name, we can see that we are focusing on emerging technology solutions to deal with our current water threats. In the bill, the bill identified 9 threats to water quality. We categorized into 4 categories. So for biological, one example would be algae bloom, so eutrophication that's caused by nutrient released. And chemical example would be acidification of water levels. Physical example would be accumulations of trash and microplastic. And the structural example would be sea level rise. And I'll go into deeper explanation on the solutions later in the slides. Let's shift our move to the Golden State, California, San Joaquin Valley. San Joaquin Valley is located to the south side of Sacramento and to the north side of Bakersfield. San Joaquin Valley is agriculture focused and generates a lot of money for the state of California and a lot of agricultural resources for the entire United States. However, due to agricultural runoff, San Joaquin Valley, 1 million people out of the 4.3 population are actually suffering from unsanitized water. And this graph shows us the community that's being affected. So basically the whole entire valley is being affected. So what can we do here? The first solution comes from our computational group. It's artificial intelligence. So scientists was able to design this artificial intelligence bot to monitor the salinity in our waterways in San Joaquin Valley. And that can help deal with the salt water intrusion comes from the San Francisco Bay caused by sea level rise. And this graph shows us the projects, and the red dots recommend shows where the AI is being implemented, which is around the San Joaquin Valley. Limitation and controversies does rise for our new technologies here. So we all know that AI uses training data to train them, to make them think. And what if the training data sets are just old? What if the training data sets are flawed? How can we make sure that our results that's being generated by these AI are still trustworthy? So here is where we bring in metrics, because metrics helps us to audit and also managing our results. One success indicator for this case study could be we can monitor that how much reduced saltwater intrusion is in the San Joaquin Valley. If the reduced level is successful, then our whole entire project the solution is successful. Our second solution falls under the engineering category, is deep soil mixing as a new emerging technology in California. So the threat that they deal with is land subsidized. This means our land is sinking because the lack of groundwater that's being pulled out from our land. So the soil underneath becomes softer and the stone underneath become loose. What can we do? We can do deep soil mixing as this picture is showing. So we insert filling the gaps that's left by the removal of groundwater with firmer substances such as cement. Controversy for this rises, as we can see on the left picture. Imagine if we replace the middle section with just pure cement. First of all, this is very pricey, so not all counties that suffer from water issues can afford it. California is very rich, so they can afford this. But also, if we want to recharge our groundwater resources, we have no choice because cement is impermeable and the water wouldn't pass. If we replace the middle section with cement, there's no way we can recharge the waterway. And you don't know if cement is going to cause future issues to other groundwater resources. So our metrics here is simply, we can just measure how much our land have sinked since we implemented this solution. And this picture demonstrates San Joaquin Valley. They have measured their land actually have subsidized since 2004. And our last solution is from nature-based category. So our threat here is excessive nutrient release, so nitrogen, and that causes eutrophication, so algae bloom. the solution to it is cultivation of aquatic species and environmental DNA. So the science behind the cultivation of aquatic species is actually restoring wetlands. And wetlands, as we learned on our ecology trip, provides us filtration of water and also removes pollution by absorb excessive nitrogen. And how environmental DNA takes place in here is environmental DNA actually provides the researchers the chance to be able to restore the ecosystem that's originally destroyed by the nitrogen-contaminated water. And the picture on the left shows us how the possibilities and opportunities of wetland removal of nitrogen and Senhuaking Valley. It's on the left side. So controversies for this does rise because wetland is not the ultimate solution at all. It does cause selenium buildup, and if we read the RSL table from our toxicology class close enough, selenium actually causes breathing issues, lung cancer, and if it comes into the human body. So wetlands does cause that to happen, so that it's one of the controversy. And the metrics to help us to guide us through this is we simply just take sampling of random either from the river or from community tap water to see if there is harmful chemicals in there. However, Senhuaking Valley failed in this metrics because all these water are random sample from their community tap water, and it all contains nitrates and bromine and all the harmful chemicals that known to human bodies. So at the end, why are we really learning this semester? Why are we learning these science and all these solutions? It's because these science and these solutions are here for us to understand the problem, and learning the solutions becomes a tool for us to be able to merge the gap between this semester to next semester, or when we actually implement the policy and using this act to be able to find a way to help people. So the picture on the left is taken from New York Times. This shows the water bottle that Senhuaking Valley people are drinking. You might say, oh, they actually do have clean water to drink, but no, that's not the right interpretation. The interpretation here is since they don't have any access to any clean tap water, they are forced to purchase expensive drinking water bottle like this. And I think it's free choice. It should be a free choice to left for anyone to be able to have access to clean tap water. And this water stress doesn't only lays on Senhuaking Valley, it also lays in the whole water stress in the whole United States, as this graph demonstrates. So we're not here just to talk about the Senhuaking Valley, but we're using this case study to draw the attention, and we want everyone to actually think about what can we do here, using the tools we have learned from this semester to go into the next semester, and what can we actually help and what can we actually do. Now, last but not the least, thanks my team, my OK manager over there, Joey, my brilliant deputy manager, Liana, my great graphic designer, Shubi and Charlotte, Wang Cheng, Sophie, and Ugrina, Ineta, Early, and my Professor Aspen, who makes us get up at Sunday morning and criticize our PowerPoint, but without any of them, we won't be able to deliver this to all of you today. And I'm ready for any question, and thank you all for your attention.